Hi everyone, we're back. We're here to do a video on grinding aluminum. We have one of the subscribers, Fischer977. He asked if we can give a few tips on grinding aluminum. Well, I talked it over with Adam. We thought this would make a nice video. One, hopefully that won't be too terrible long. And we'll give you some pointers, but I'm going to tell you right up front that I've ground very little aluminum. I've like soft cold roll steel. We've done a video on that as well. When you get soft materials, they're kind of hard to grind. Most of my experience has been in harder steel. So most of the wheels I bought, I have a softer bonding. And what you'll see on your wheel, we'll get to that in a minute. But anyhow, the bonding on that, it goes from A to Z, and you'll see those markings on your wheel, and the softer bondings will be A, the harder bondings will be towards the Z. So the wheels I have are probably kind of medium to soft. I go from, I believe it is I to K, let's see, a G, maybe it's G to K. But also in there we have different structures on the wheel. So if you can see right here, one of my favorite wheels that I use has got this very open structure, and it's a ruby aluminum oxide. And one of the things you'll find with cutting soft steel, aluminum, cold roll, what happens is your wheels will load up real fast. The particles that you are cutting, as you cut them, they're soft and they wrap around, and we've done some videos where we showed the close-ups where you can actually see how the material is wrapping around the individual grit. And what happens when that soft material wraps around that individual grit, as you come for another pass or you're going to keep going, your stone, the cutting edges are not touching. What's happening is metal rubbing on metal. And so now your finish starts getting bad. It sounds like you can hear a lot of more pressure being applied on the wheel. Things can heat up if you're doing thinner plates, and it can get pretty ugly real quick. So anyways, with this open structure, one of the nice things is it gives a lot of space between the grit for materials to be able to get in and hopefully wrap out. Well, this wheel right here is an open structure as well, and that wheel, it's got a ceramic and aluminum oxide mix, and again, it's more for a harder type material. I have no idea how it's going to cut in aluminum, so there's going to be a lot of this stuff that I'll be learning along with you. Now, this one right here is my hardest wheel, and that one is the K structure, but it's a closed bond. It's very smooth, and so I think that's going to be what's going to hinder us in this one. And then we have the white aluminum oxide. It's a 46.2, meaning that it's 46 grit and it's got 0.2 of a finer grit. And that one actually cuts pretty nice. It's just a real good general purpose wheel. And so what we thought we would do is we'd try some of these experiments like we've done in the past and apply them to aluminum. And I've never used some of these wheels over here to try cutting aluminum. I think the problem I'll have is that because they're a softer bonding made for a harder wheel, I'm not going to probably get the optimal performance that we need. And the general rule is if you have hard material, you use a softer bond. If you got soft material, you use a harder bond. And I don't know how much I will buy into it, how far you can go with that. I don't have enough experience to tell. I'd rather prove this stuff out myself. But the idea with the harder bond is that soft material is not going to wrap around each little grit and start pulling it out and change the shape of your wheel. The trouble is when it starts loading up on the leading cutting edge, it's going to load up fast, and you can have all the open grit behind that. If your leading edge is what's loading up, you're in trouble. You would almost have to take a wide traverse, I'd think, in order to get a harder wheel to cut good. And again, there's a lot of little things you can do. But so anyways, today hopefully be a learning experience for all of us. We'll try some of these wheels. I got a block of aluminum over here that we'll try cut. I can tell you right now that if we cut and I flood it with coolant in the past, I've never had success with that at all. What we have done is we've taken undiluted coolant. And what we use is an oil base. It's water soluble. And it's a Simcool, a Simperol 1070. And so with that, I just poured some right out of that 5-gallon bucket into here in this little jar. And I'm going to use this brush, a modified toothbrush. If you have children, you probably have the same problems I do. I had some nice small paint brushes that I could use for that. But my daughters decided that they needed them more than I do for some of the house projects. And I really can't get too mad at them because they're doing a lot of house projects that are really helping out a lot that I just don't have time for anyhow. But it does get a little bit frustrating sometimes when you spend a lot of time trying to find something you know you have, and then you find out that, well, it's been used for other things. But anyways, what we're going to do, I don't know how well this modified toothbrush is going to work, but we're going to use that, and we're going to come up and we're going to just take a straight, non-diluted, and we're going to apply it to this surface over here and just get it real good. And I'm just going to theorize what's happening is this stuff, when you put it on, this stuff is super slippery. And I think what happens that when that aluminum comes off and is painted on there, it's so slippery that the centrifugal force that your wheel generates over there, it keeps most of that aluminum from wrapping around the individual grit and sticking on. But the drawback is grinding aluminum is slower. You have to apply it every pass. And so what I'm going to do, I'm going to take this wheel. It's an open structure. It is, I believe, the eye hardness, if I remember correct. And we're going to come across there and we're going to see what it looks like as we grind. I'm real close. I still have to touch off. Put these wheels over here. Now that feels real smooth. The finish, you can see some lines in there, and I know I'm going to have trouble getting a real good finish, but I'm going to guess that it come out pretty flat. Okay, that was probably about a 5/10 pass or so. Like I said, I just want to see what kind of finish we're going to get. What I'm going to do now, I set my digital at 0. I'm going to paint this off, and I'm going to see how many passes I can get before that wheel really loads up on me. And we'll just take a thousandths at a time. So it's going to be kind of a heavy cut. That's the other thing I know with this aluminum. You don't want to leave a lot of stock on it. You want to get it close. You want it to be flat, parallel, and square. The least amount of grinding that you have to do on it, the better off you're going to be. Other thing that you might want to do, which I probably should be doing, but it's going to make it hard to talk, is wearing a mask because you get that aluminum particles in the air there. You want to really not breathe that. Once you get me a mask, Adam. That finish is just as good as the first. There's one towel. So the plate's not hot, it's room temperature. It's grinding real nice and cool. Yeah, I think I'm going to go ahead and put a mask on because I just don't like the idea of all this aluminum being hanging in the air there. Adam, why don't you come and take a close-up, because it looks like the finish is actually getting even nicer. And again, no heat in the part, sounds good. I've got my fingerprints all over it. One of the things I did not do is knock the loose grit out of it, and so maybe that has come out, and that might be why the finish is getting better. Some of the previous videos, you'll see I'll take a popsicle stick and I'll knock the loose grit out. I didn't do that on this to start with, but I did notice the finish, at least with the naked eye, looks actually better now. And this is after 3/1000ths. This method actually works pretty good with cold roll steel as well. And the other thing that with this porous, I know when I would grind brass and cold roll to try to load the wheel up so that you can see the little particles wrapping around the wheels, it was extremely hard to even load these up. So that's one reason why I wanted to try it on this aluminum, to see if we'd get the same results. Thousandths, finish is sweet, no detectable heat other than what it was from the last pass. $11,000ths without dressing the wheel. I mean, it sounds great. I think it's going to wear me out before I wear it out. Thing sounds awesome. It don't sound any different from the very first cut we made. I have a pretty heavy traverse cut in the Y. As you can see, I'm continually moving because I'm just wanting to blast this stuff off of there. No difference. It actually sounds better now. That's 20,000ths. $20,000ths, no difference. Adam, why don't you get a close-up on here and show them the finish? Just so you can see the surface, we got just a little over 2 5/8 by about 2 3/4. I think we might have a winner without even going further, but I know Adam's going to have to speed things up. You guys are going to get bored and fall asleep. Yeah, I'm real happy with this. This blows me away right now. I figured that thing would be too hot to touch. You got to remember, that's 20 thousandths of soft aluminum coming off of there. I mean, it sounds super. We're at 21 thousandths. 24. Everything pretty much the same. Beautiful. That's 30 thousandths. Finish is beautiful. Hardly any heat. I'm just going to do a finish cut from here, but before you do that, I want Adam to take a picture of this finish. And I'm going to see if I can improve the finish a little bit by taking a lighter cut. What I'm going to do, because it got just a little bit of heat in it, the wheel's kicking down some air on here. I'm going to just let it set for a little bit right here. Take some of the heat out. I tell you, if you're not used to these masks, they start hurting your nose here pretty soon. What we'll do is we'll take a light cut, get a finish. I'll try to get that cleaned off as good as I can without making a mess on the surface table there, and we'll check it for flatness. Oh yeah, that's real nice and cool right now. I'm just going to take off 2 or 3 tenths. It doesn't even sound like I'm hitting, so I'll probably take another 2 or 3. You can barely hear it. I can hear it in the back, barely hear it here, so I'm going to take off about another 2/10. Finish is awesome. I'm going to blank pass it. Okay. That's about 31 thousandths. Blows me away. I'm going to try to clean this up a little bit, and then we'll get it on the granite table, and we'll try to see how flat this surface came out. Well, we're back. It took a little bit to clean that coolant up. My hands are still slippery. I turned the wheel off. We'll go back over there in a minute, and we'll actually look at the wheel. But first, before I put the indicator on here, I'm hoping that I didn't bump this while I was cleaning it off. But I just wanted to show the finish, because I'm pretty sure when I run my indicator across, it's going to leave some marks in there. But we got an excellent finish. We ground 31 thousandths off of this. It's about 2 5/8 square. We dressed the wheel the very first time. We didn't dress it after that. So 31 thousandths from the dress to where we're at right here. And now we want to check and see the finish is awesome. We want to check and see how flat it is. And again, I'm hoping that I didn't move and you can see that's pretty darn flat. You're really supposed to move the part rather than in the indicator. But I can feel stuff under there a little bit. But even with that, it looks like we're less than 1/10, probably closer to 50 millionths. That's, in my opinion, that's quite awesome, considering that's 31 thousandths that was taken off on there. Finish is excellent. The flatness is, I mean, it's great. For surface grinding, it's great. Let's go to the surface grinder now, and let's look and see the wheel and see if we can see a load up on that and what it looks like. Yeah, so as you can see, we got some loading. It's kind of dirty, but with all this open structure, this is one reason why we weren't generating heat, because it allowed that undiluted coolant to just work right in there, and it helped. I'm sure what it did, it helped keep this from loading even worse than what it is. And you got to remember, this is 31 thousandths taking off, and this is the condition that we have in the wheel. I'm really impressed. So this wheel, and again, it's a soft. It's a it's Radiac RAA 46 grit. It's an H800, and the VOS, meaning that it's the open structure. And I figured this one would work pretty well because of the fact that the success I had in cold roll and trying to load it up in brass. I'm not going to try all those wheels. This took a long time. What I'm going to do is I'm going to pick the wheel that I think is the most likely to fail and pop that on there, and let's compare it with that. And so that wheel, I'm just going to take a guess, is going to be this wheel right here. You can see the structure's a lot, it's closed. There's not as much open space between the cutting edges. Not only this is a ceramic mix, and ceramic typically doesn't like the soft stuff, it likes hard stuff. So this is a Radiac. It's a 8 BP60 K8, so it's a harder wheel. And again, the conventional wisdom is that soft material, you use a harder bonding. This is the hardest bonding I got, but it's a closed structure. So as far as the bonding is going to be better, but I think the closed structure is going to be what's going to burn us on this one. So I'm going to get this one set up. I'm going to get it dressed off, and we'll get set up, and we'll come back and we'll see where this one will go. Okay, we got the 60K. This is a ceramic aluminum oxide mix. It's a closed structure, and I will be surprised if this will work or come even close to what we had with the other wheel. Okay, we just touched. Back it up. Set 0. We'll take 1/1000 off. Sounds real nice. Finish is suffering from what we had, even though we got a coarser wheel. Keeping things the same. I didn't knock the loose grit, so what we'll do is we'll get a few more thousandths off it, and then we'll compare the finish, because it actually improved about 3 or 4 thousandths down. Sounded nice. Finish is a little bit better, but still not as good as the first wheel we had. Three thousandths. Finish looks a little worse. Okay, we're at 4 thou. Yeah, you can feel heat in there, and that's not surprising because we got closed structure and a finer grit, and then the ceramic. That's at 7 thousandths, and it's got quite a bit of more heat than what we had at 31 thousandths with the other wheel. The finish, not as good. What we're getting over here, we're getting that aluminum probably rubbing. As it wraps around the wheels. That would generate the heat, and it would give us that rubbing look that we're getting. There's 8 thousandths. But even with that, with the 60 grit close, I think the key is applying straight undiluted coolant. I think that's probably one of the keys right there, if not the most important. Also, I like using a cluster diamond when I use my dressing over single point. I usually get better results with that. Yeah, I'm going to stop right here. We're 12 thousandths, the block. is definitely getting warm enough that it's going to cause problems of stability as far as getting it flat. I'm going to just let Adam come up here and take a close-up so you can see the finish. You can see that there is much more rubbing. I doubt I'd be able to get to 30 without that thing getting probably almost too hot to touch. Yeah, this video is starting to get way too long. Adam's going to be up all night editing. But the key, this first wheel, in my opinion, blew this 46 grit. The H did outperform this one. What would be nice in the future is grab this wheel in maybe a K hardness and see if it's even better than this. And maybe someday when I order wheels again, I may do that, because I know if it works good here on this aluminum, it should work good with soft cold roll too. They generally be the same. But the key right here is using that coolant, using it straight, brushing it on. 31 thousandths with the other wheel. This thing, you could barely tell any heat. The finish, you saw the finish, you saw the flatness. Everything was great. And so anyways, if we have some of our subscribers, viewers out there, if you have other tips and techniques, I'd really appreciate it if you would throw that in the comment section. For you guys that are struggling with grinding aluminum, I would get that first wheel. I would get that. And again, I don't know about other brand names. I'm a fan of Radiac. I know the bonding, a lot of times, if you go from like a Radiac to a Norton to some other type of wheel to a Camel, even though they all might be an H or K bonding, those bonding between one company to another can vary to a degree. So you'll have to experiment, try to get the equivalent. And I'm not sure if there's anything on the internet. I'm guessing there probably is that might be able to tell you. Maybe someone's done the research where they can tell you whatever brand name, what the hardness, and kind of get kind of an equivalent. But anyways, hope this video was a benefit. And again, we did this at the request of Fischer977. We hope they answered some of your questions. If not, put some comments down in the section, and maybe there's some other things we can try in a future video. Anyways, thanks for watching. We'll see you next time.